This week has introduced you to the various techniques we use to prove programs correct. And hopefully you found this enlightening. Hopefully you recognize that coming up with the proofs are a bit of a puzzle. Parts of it are very systematic. Parts of it, like the proofs themselves, require you to have a certain amount of experience as you put the pieces together. The question, of course, is this worthwhile? Isn't this a lot of work? Wouldn't it be better to just kind of test things? Isn't it the case that we're only doing this for very simple programs? What if we have double nested loops? What if we have triple nested loops? Well, that's where we get to the title page of this particular unit. Don't panic. Where does that come from? Well, one of my favorite books is Douglas Adams' Hitchhiker's Guide to the Galaxy. Not much of a movie, but really quite a funny book. And the Hitchhiker's Guide has "Don't Panic" in large friendly letters on the cover. And similarly, I'd like for you to not panic. Don't let what you may perceive as complexity when it comes to the actual proofs get in the way of understanding and finding out how useful this actually all is. And you're going to find out it's extremely useful. At the very least, the way we kind of structured the proofs around what turned out to be these various worksheets that allow you to check whether different parts are correct, relates to how you should be thinking as you program, even if you don't take the very formal approach that we're now trying to teach you. Let's move on to some more words of wisdom. In Dijkstra's The Humble Programmer, the acceptance speech for his Turing Award, he points out, but one should not first make the program and then prove its correctness, because then the requirement of providing the proof would only increase the poor programmer's burden. So what this really means is, look, don't hack together a piece of code, whether it's pseudocode or real code, and then try to prove it correct, because then you have to go through all of the steps that you just learned, and you may find this overwhelming, and the temptation would be there to just skip it. Instead, as you are designing the program, as you are developing the program, you should build the proof of correctness into your thought process, and importantly, into the derivation of the program itself. Okay, so that's the second part of this quote. On the contrary, the programmer should let correctness proof and program grow hand in hand. And what we've really discovered over the years is the wisdom of exactly that. And what you're going to discover in week 3 is how to do this for simple programs, and then in weeks 4 through 6 for much more complicated operations that we've encountered in the field of dense linear algebra. So, week 3 will all be about the goal-oriented programming that Dijkstra advocated all along. And you're going to learn how to derive programs hand in hand with their proofs of correctness. And you're going to actually find out that doing that is easier than a posteriori proving your programs correct. So, don't panic, hang in there, it'll all be okay.